Okay, so hello everyone, welcome. Okay, can you hear me? Okay. Okay, just we are waiting 1 or 2 minutes for joining all of the other participants, then we will start our today's class. Okay, so now we'll start our today's session. So hello everyone, welcome. Hope all are you well. So basically today is our sixth number of class. So basically today I will try to discuss about that classification, land use, land cover classification using the different types of machine learning method, how we can easily apply and also get the result about that classification. Okay, such as different types of model such as random forest, then classification, regression trees, support vector machine or other types of model, how we can easily implement in here, and then we can easily get the result about the land use land cover classification map. Okay, so let's go start. So I simply share my screen. Okay, so now can you see my screen? Yeah, so now it's visible. Yeah. Okay, so let's go. So basically today is our sixth number of class. So basically today I will try to discuss about that how to make the land use land cover classification using the different types of machine learning method. Then how to make the land use land cover classification chart and how we can easily calculate the classification area. How to add the legend on your land use land cover classification map, and also how to calculate it, the accuracy assessment of land use land cover classification map such as kappa coefficient as well as also overall accuracy, then producer accuracy and other types of accuracy, how you can easily calculate it. We also try to discuss about this. Okay, so let's go. So first of all, when you want to make this any types of land use land cover classification map using Google Earth Engine platform, we have to follow the some process or step, and this step and this process is the same when you want to any kind of land use land cover classification map. When you want to create, just follow this same process. Okay, so first of all you have to selecting your region of interest. So which area you want to need? Suppose you want to make the land use land cover classification map for Dhaka city. So first of all, you have to import it, the area of Dhaka city as a shape file. Okay. Which area you want to need for the classification? Just simply selecting, or you simply import your shape file in Google Earth Engine platform. After that, you can simply choosing and filtering the image collection. If you want, you can use here the Lancet. If you want, you can use here the Sentinel. If you want, you can use here the Modis. You can simply choose and then filter this image collection. So mainly when you filter, some factor is different on the filter, such as your time period, then your cloud cover, as well as also a specific area. Okay, so we already discussed about the filtering process for the image collection, such as Lancet and Sentinel. Just simply filtering the image collection, choose and then filter. And third process is that you need to some collect the training point from your satellite images. Suppose you want to classify total 4 class: water, build up area, vegetation, and barren land. This total 4 class you want to classify from the satellite images. So you have to collect the training point for water, you have to collect the training point for the vegetation, you have to collect the training point for the build up area, you have to collect the training point for the barren land. Okay, so it's just simply collecting all of those classes training point, which class you want to classify it. After that, you need to merge all of the training point together. Simply merge all of the training point together and make a store all of those training point in a one variable. Okay, simply merge and in one variable you can simply store all of the training point. Suppose you want to take the training point. Suppose you take the training point for the 20 training point, you can get the for the water. 30 training point for you can get for this build up area. Then suppose 22 training point get for the barren land. So all of those training point you can simply store in a one variable or merge all of those training point together. Okay, so after that you need to make a training data set. Okay, so in this time when you want to make the training, you have to create the prediction band, the training data set. Okay, suppose in this time you want to use that all of those RGB band. Okay, red, green, blue, also near infrared, short wave infrared 1 or short wave infrared 2. Okay, simply take all of those band, and from this band you extract the band pixel value from this training point. Suppose you take the training point for the water body, 20 training point. So you extract the band value for all of those training point of water. Same as like for vegetation, then build up area, as well also other classes. Okay, so we can easily take the training data set in Google Earth Engine platform using the sample regions function. Okay, after that we can simply divide the data set two way. Some data set we are using for train our model, and some data set we are using for test our model. Suppose this ratio can be 80% data for train your model and 20% data for check your validation. Okay, so after that you need to create the classifier. Mainly classifier, it will be different types of classifier is available in Google Earth Engine platform. It can be random forest, it can be classification, regression trace. Okay, you can just make the classifier, create the classifier and classify your image, as well as also create the classified image and then display the result, and then also need to print the confusion matrix for your accuracy assessment. Okay, we also try to show you that how you can easily do that for accuracy assessment using the confusion matrix table and calculate the area for each classes. Okay, so let's go. I can simply open my code editor and try to show you the practically. So just I simply open my code editor and try to show you practically. First of all, you can simply go to the asset tab. Suppose in this time I want to create the land use and cover classification map. for the Dhaka city. Okay, so for that I simply import this boundary shape file in my code editor. So just simply import that. I simply import this and put this name such as ROI. Okay, and then I display the result as a layer. So use the map.add layer function and call this ROI, and also focal the center of the shape file. So use the map.center object, and object is the ROI, suppose 10, and click to the run. So this is my study area. Okay, so this is my study area. I want to make this land use land cover classification map for this region. Okay, so just I simply import my region of interest. So my first step is done for selecting ROI or region of interest. Then move to the second step, choosing and filtering as collection. In this time you can use the Lancet, or if you want you can also use the Sentinel. There is no problem. So I want to use here the suppose Lancet. Both of the process is the same. Okay, so I also use here the Lancet image, and you also try to for the Sentinel imagery, Sentinel-2 satellite imagery you also try to use for the classification. In this time I want to work for the Lancet 8 image collection. Simply click on here. So mainly for this land use land cover classification map, mainly we are using here the surface reflectance imagery. Okay, so just I simply open the surface reflectance imagery. So I need to import the image collection first. So simply copy that. Simply copy this artisan snippet from here and then paste and give a variable name. Suppose put the name is that L8. Okay, so now this is my image collection. This image collection I choose. If you want, you can also choose the Sentinel-2 satellite imagery. There is no problem. Okay. In this time, I choose my Lancet 8 surface reflectance satellite imagery. So now this image collection I need to filter. Okay. So this image collection I need to filter. So let's go. We take the filtering. So mainly I also write the comment. Suppose filtering. So mainly filtering. Mainly where, then when, and how. Okay, so these three factors depend on the filtering. So first of all, I can simply take a variable. Suppose I put the variable name is that yes, okay, and then call the L8, because this L8 is stored the full image collection, okay, for the whole world. But in this time, I don't need for the whole world. I need only for the Dhaka city region. So just I simply use here the filter bounds function. We already discussed a lot of time about this type of function, filter bounds, also filter metadata. Okay, then I put here the suppose I put here the filter date function. Suppose I need to make the land use land cover classification map for year of 2022. Then 1st January I take the whole year 2022, December 31. Okay, so in this time I also set here the metadata function, because I need only for those images which image will be not more than 1% cloud cover. Put here the cloud cover and set the operator less than 1. Okay, so now if you want to check, suppose you from this year of 2022 you want to work for the single image. Okay, then you can simply filtering all of those things, and then you want to check how many images are available. So just I simply use the print function and use the image, and then click the run. In this time I can get all of those image information according to this condition. Okay, so here I can get total, you can see how many images, 9 images I want to get in here. So here you can see total 9 images also get there all of this image information. You can see the first image is the year of 2020, 16 February, then 4th March, 20 March, 31 January, 16 February. So in this time you can see all of those images has a total 19 bands. Okay, so when you want to work for the single image classification, just what can you do? Just simply copy this ID copy this id, and then simply take a variable. Suppose I put the variable name is that single image. You can use any variable name, then put here the e dot image and put here. Okay, so now this variable is stored only for this single time period image. Okay, which capture year of 2020 22 20 March. Okay, it only a single image collect. So you can simply show the image. So simply use at the map dot add layer and then simply copy and click to the run. In this time period image only for the single date image with acquisition date is that year of 2020 March, it will be appeared in here. Okay, so just you can simply clip and then work with that. Okay, but in this time I am not working for the single image. I want to take all of those images, median image collection, total 9 images. These 9 images I create the median image collection. So simply use at the median, and it also clip with my shapefile. So shapefile is that ROI. Okay, so now let's go display the result of our median composite from total 9 images. So simply use at the map dot add layer and then call the image. Object name is the image. Okay, now click to run. So now it display the result about that. So I just simply add here the visualization parameter, otherwise it look like the black color. So just I simply use here the suppose B4, then B3 and also B2, custom 98% for better looking, and then apply. Okay, so now you can see I got my satellite images in here, year of 2022. Okay, so now these satellite images I simply classified. Okay, so this is our second step for choosing and filtering the image collection. When you want to work for the Sentinel, same process. You can simply choose the Sentinel-2 satellite imagery and then filtering your Sentinel-2 satellite imagery. Okay, so now our third step is that we need to collect some training point. Collect training points. Okay, for collecting training points, so mainly for collecting the training point, we are using here the different types of spectral indices for identify the different types of feature from the satellite images. Okay, so in this time this band combination you can see. So mainly this band combination called the red band, green band and blue band. Red, green and blue, it create the composite about that natural color. So natural color we can easily identify. You can see this type of green color, it's identify the vegetation. Okay, this type of identify the build up area, and this is the water body. Okay, also you can see the barren land. This type of result is the barren land. Okay, we can easily identify. Okay, when I use the band combination natural color red, green and blue. If you want, you can also use at the another types of band combination. Suppose I want to use at the near infrared, then red, and then blue. Okay, custom 98% for better looking, and then put here the apply. So now I can got this type of band combination. It's called the false color composite. So mainly when you are using this type of band combination, it's showing the water body as a black color. Okay, you can see the water body as a black color, and dense vegetation is looking as a red color. You can see dense vegetation will be this type of color. Okay, red color. When I use the band combination, then dense vegetation will be look like as a red color, but water body look like as a black color. Okay, or dark color. You can see. Okay, also if you want, you can also use here the another. Suppose you want to use here the short wave infrared one, then put here that suppose near infrared, and then put here the green. So then apply. In this time you can see In this time we can get the result look like that. This type of brown color, it's identify the build up area. Okay, you can see this type of brown color, it's identify the build up area, and this type of green color identify the vegetation. Okay, also you can see the water body will look like as a black color. Okay, so mainly when you want to take the training point from the satellite images, then we are using here the different types of spectral indices, different types of band combination. Okay, for identify the different types of feature better. Okay, so now you can say I can easily identify this is the water body. So just I can simply take the training point as the water body as a drag place. Okay, so that's what can I do, just simply click on here. Geometry you can see it will be apparent default. Simply click on here and then put this name as a water. Then feature collection property. In this time property I choose here the suppose class and set the value 0. Okay, property name is the same when you want to take the training point for the build up area or vegetation, barren land, all time the property name will be same, just change the value. Okay, so water will be 0, then we can put here the suppose build up area, then build up area will be 1. Okay, so look like that. So just I simply click the OK, you can see now it will be showing the water, and then you can simply click on here, now it will be bold font you can see, and then take the training point from the water body. You can see I simply take the training point from the water body. Okay, and we are using here the different types of band combination for identify the different types of individual feature. In this time when I use this type of band combination, then water body look like as a black color. Okay, so you can see I take the one training point for the water. Okay, so then take the new layer and now click on here. Suppose in this time I want to take the training point for vegetation, just simply click on here, write the name vegetation, and then simply select this feature collection and property name will be class, and set the value for vegetation 1. Okay, then okay. So now we can easily identify this type of green pixel will identify the vegetation. Okay, so then I simply click on here vegetation. And you can also open the satellite view map for better understand about that. Okay, so mainly this type of vegetation is the cropland. Okay, we are also help of the base map this type of satellite view, then you can easily identify. Okay, so then I simply pick the new layer and take the training point suppose for barren land. Simply click on here, barren land, their collection, property will be class, and set the value for 0, 1, 2. Okay, so I simply you can see first up water will be 0, then vegetation is the 1, and then barren land is the 2. So just I simply take the barren land training point from the satellite images. You can see this type of brown color identify the barren land. So I simply take this training point for the barren land. Okay, and finally I take the also training point for the build up area. Simply new layer and click on here. Suppose I put here the suppose build up, and then import as feature collection property. Property name will be same class. You can use any name, there is no problem. But all of those classes name will be same. And put here the 3. Okay, then okay. So now we can easily take this training point for the build up area. And you are use here the different types of band combination for identify the different types of feature. Okay. Suppose in this time I want to use here the suppose natural color, then B4, then B3, and B2. So mainly it's mainly showing the visualization about the satellite images. And we are using here the different types of band combination for identify the different types of feature from the satellite images. So in this time we can get the feature look like that. So I simply take this training point as a build up area. So build up area, I take this training point.
Sir, how many points do you need for the
Okay.
training data?
So basically it's depend on your accuracy. If we are get the accuracy is the low, then we are also increasing the training point. But minimum 50 training point is enough. But
Because
yeah,
the built area is a different type of built area, because it
yes,
is maybe it is a road, or
yes,
it may be the building.
yeah,
So I think that yes,
yes, yes. So all of those things, road, building, then settlement, all of those things we consider as a set build up area in this time. So we take the training point more for this for the build up area. Okay, and if we are when you can check the accuracy about that, suppose consumer accuracy or producer accuracy, his accuracy is not good, then we are also for this class we are also increasing or decreasing the training point about this class. Okay, so let's go. First of all, we take the training point randomly, and if we are not get the good accuracy about this, then we are also increasing or decreasing about our training point and also classified again. Huh? Okay, suppose I take this training point look like that, because there's a lot of build up area for this region, so that's why highest number is the build up area training point I can got in here. Okay, so let's go. So in this time you can see I take the training point for the water body, vegetation, barren land, build up area, total 4 classes. Okay, so I take the training point, collect the training point. Okay, so in this time we also need to merge all of those training points. So merge. For merging, what can we do? Just simply take a variable. Suppose put the variable name is a sample. In this variable, I store all of those training points together. Okay, so just simply merge. So just use that the water merge with suppose vegetation, and vegetation merge airland. That's why merge all of the things. Now let's check about the print. So I simply print sample. Now we can get total training point. All of how many training points I can got for all of those classes. So here I can got total 290 training point for all of those classes. Okay, and now you can check about this. You can see all of those training point, and all of those training point already categorized. Suppose you can see 199 this number of training point. What is this class? You can see this class is that class 2. Okay, already categorized about this. What is the class 2? You can see 0 is the water, then vegetation, barren land is the class 2. Okay, so all of those training point already categorized because it is a supervised classification. Okay, so supervised classification method, we are mainly I think some person will join. Okay, so first of all we need to categorize data about that. Okay, so for that you can see all of the staining point has already categorized. Okay, suppose this staining point you can see for this staining point is that class 3. What is the class 3? Class 3 is, you can see 0 1 2 3 build up. Okay, so all of the staining point we can got in here. So in this time what can we do? Just we can simply extract the band pixel value. Okay, we can simply extract the band pixel value from all of the staining point. Here we can get total 290 training point. 290 training point, extract the band pixel value from the satellite images. And now which band you want to use for extract the band pixel value, you need to make a list about that and also extract this band pixel value. So let's go. So you need to simply select the bands. So I simply take a variable and make a list which band I want to extracting the band pixel value from all of the staining point. Okay, so take a variable, suppose put the variable name is the bands. Okay, and make a list. So in this time, suppose I want to need for the SR B1 and also need for SR B2, as well as I also put here input here the suppose SR B3 for the green band, SR B3, then red band SR 4, then near infrared band is that SR B5, then short wave infrared 1 SR B6, and short wave infrared 2 SR B7. Okay, so I want to extract all of those band value. Suppose total 299, all of the staining point, extract all of those band value. Okay, suppose you can see first staining point 0, extract all of those band value. 1 extract all of those band value. 2 extract all of those band value. 3 extract all of those band value. Okay, so in this time this is my band. I want to extract all of those band value from all of the staining point. Okay, so let's go for extracting the band value. So basically this band value is my training data set. Okay, so in this time we talk about the create the training data set. Okay, so I write the comment, suppose training data set. Okay, so training data set, for that I simply take a variable, suppose put the variable name is that training. Okay, in this time I want to extract the pixel value, all of those band pixel value from this image, and you can see what is the image variable name. You can see basically I want to use this image in here. Yeah, so this is my image. You can see this is my image. Okay, you can see this is my image. Okay, this is my image. So I simply call the image and paste here. Okay, from this image I need to use the select function. So I extract all of those band. Okay, and all of those band is stored in a variable. What's the variable name? Variable name is the band. Simply copy the band. So from this image I select all of those specific band which I want to extract the pixel value, and then use the function sample regions. Okay, sample regions. So mainly this function used for extracting the pixel value. Suppose you have to some collection about the point. So now from this point you want to extract the pixel value. So then you are using the sample region function. Okay, so I simply make dictionary. So use the curly bracket and also put here the curly bracket in, and then collection is that your all of the staining point. Okay, all of the staining point is stored in a variable. This variable name is the samples. Simply copy the samples and paste there. Then properties is that your property name. You can see the property name is that, you can see the property name is the class. Okay, and all of this property is same. For you can see vegetation is also class, barren land is also class. Okay, so properties name is the same for the class, and it is a list. List means that it is a not singular form, it is a plural form. Okay, so for that you have to use here the curly bracket and put here this class. Okay, because it is a not singular, it is a plural form, properties. Okay, so that's why I need to use the square bracket and then put here this property name. That is scale. Scale is the resolution of your satellite images. In this time, resolution is that 30-meter resolution. Okay. About the data set, mainly it is extracting all of those band pixel value from all of those training point. So just I simply copy the call the training and then click run. So now we can check about our data set. And further, we also need to divide the data set in a way. Okay, some data set we are using for train our model, and some data set we are also used for check our validation. Okay, so let's check about the training point. You can see all of those training point. Okay, you can see. Suppose you can see 0 number training point. You can see total 8 values for that. Suppose 1 number training point, you can get total 8 values. So all of those training point extract their band pixel value, and this is my training data set. Okay, this training data set in this time I randomly separate. Suppose some data set I use for train my model, and some data set I also use for check my validation. Okay, suppose for the accuracy assessment we are need to the test data, and for the train our model we need the train data. Okay, suppose in this time we want to revert some of the data for testing and to avoid the overfitting the model. Okay, and suppose in this time roughly 80% data for train our model and 20% data for testing our model. If you want, you can also use for the 70% data for train your model and 30% data for test your model. Okay, roughly. So let's go about that. This is one training data set. All of those band value store it in this variable, and this is my data set. This data set I divide into two way. Okay, so let's go. So for that, in this time, suppose I also write the comment. Suppose in this time I roughly suppose 80% data for training and 20% data for testing. Okay, so now I simply divide the data set into two way. Okay, so for that, and this approach will be randomly. Okay, randomly I take the data set. Okay, so for that, what can I do? Just I simply take a variable. Suppose I put the variable as a train data. Okay, in this time, this all of those training data set I need to distribute as a randomly or roughly. Okay, so for that I simply call this variable name and paste here and use a function, this function called the random column. Okay, so mainly this random column function distributed the data is a randomly and stored it in this variable. Okay, so now this data set I just simply roughly 80% data for training and 20% data for testing. Okay, so let's go about that. We can simply filter the data set. So just take a variable. Suppose put the variable name is that train set. Okay, train set, and then I simply call this variable name because it destroyed all of those data. From this data I simply take for the 80% data for training or train set. So then use a function, suppose filter, and use the earth engine filter dot. Okay, so in this time suppose use the less than put here the random 0.8. Okay, and after that take the another variable, suppose test set, and call the train data, and it also filter. And how I can filter? I do filter in this time greater than or equals less random 8%. Okay, so use the earth engine filter greater than or equals randomly 0.8. Okay, so now I take the 20% data about the test set. Okay, so just we can simply divide it the two way about this data set, and now this train set I use for train our model, and this test set use for check our validation. Okay, so for in this time when you want to train your model, you need to make a model. Okay, it's called the classification model. So in this time my dataset is ready for the train set dataset, and test set dataset is ready. In this time this test set and train set I want to input as in a model. Okay, so in this time this model I need to create. Okay, so let's go about the for creation about the model. So classification model. Okay, in this time we are using here the different types of model. It can be classification, regression trees, it can be a support vector machine. Okay, so let's go about that. We can simply create a model. Okay, model, it's also called the classifier. Okay, so I just simply use variable suppose classifier. You can use any variable name, there is no problem. And in this time I want to use here art engine, suppose classifier, then file cart. Cart means that classification and regression trees. So cart, and then suppose this is my model, and this model I want to use for train. So use at the train function and put all of those argument about the train function. So just simply make a dictionary, curly bracket start and curly bracket in. First of all, feature. So just simply call the feature. So feature in this time for train our model we are using here the train set 80% data. So simply copy this and paste here. In this time class property, you can see it will be property, so that's why simply use here the class. Okay, so you can see our property name will be class. All time we are using the class, so use the class. And in this time it is a singular form property, so that's why we don't use here the square bracket. Okay, but you can see for the properties you must be using the square bracket, otherwise it's showing as a wrong or error. Okay, then input properties. In this time in this model you are put input properties is that our band. You can see all of those band. So simply copy and then paste here this variable name. Okay, then it's not it, I simply know. So now our model is created. Okay, so this is our model. Okay, so when I apply this model on this satellite images, okay, which I create in here, this satellite images, then it will be classified and display the result. Okay, so let's go about that. We check add this model with our images. So classify the image. So what can we do? Just we can simply take a variable. So I also classify the image. Okay, so this is our model. Okay, so in this time this model I want to use and classify this satellite image which I create in here. So for that take a variable, suppose variable name is the classified. You can use any variable name, I put the classified. And then first of all I need to call my input. In this time I put the input, this is my image. Okay, so this image I want to classify it. So just I simply copy this variable name image and paste here, and also use a select function. Okay, select and which band I want to use in here. So I use all of those band. So simply copy the band values, band variable name and paste here. Okay, so now this is my input. This input I need to connect with my model. This is my model. Okay, this is my input and this is my model. I need to connect. For connecting I simply use a function, classify function. So classify function and simply call this model variable name. Simply copy and paste here. Okay, so now this image is the classified. So let's go about that classified result. So simply I display the result. Okay, so the result. So take a variable, suppose map.add layer, and then call this classified. Okay, then click to the run. In this time you can see one layer also added in here, but we did not get anything because I did not use the visualization. Okay, and when I want to add the visualization, then we can easily identify about that all of those classified area. In this time it look like that. Okay, so now let's check get add the visualization. So make a dictionary and put here the mean. It will be start from the 0 and max up to 3. Okay, because you can see it I simply put at 3 because you can see the max value build up will be 3. Okay, so that's why I simply use at the 3. So now I want to add here the color plated about that, such as you can see for the 0 is the water. I want to show water as a blue color. Okay, then vegetation as a green color, green, then barren land yellow, then what build up area red color. Okay, so now click to the run. Now it appeared the result about this land use land cover classification map. Okay, so now again, so we can get the result look like that for this classification. Red color is identify the build up area, all types of build up area, settlement, road, also all of those things, as the red color is the build up area. And then the blue color identify the water body, and also yellow color identify the barren land, and then also green blue color is the water body. Okay, then green color identify the vegetation. Okay, this is the vegetation part, and this type of water body in here. Okay, so this is our classified map we can get in here. Okay, so not only for that, in this time first of all we need to check about that accuracy. Okay, we can check the accuracy. If the accuracy is not good, then we also try to use here the different types of approach for increasing the accuracy about this land use land cover classification map. Okay, there are a lot of way for increasing the accuracy about the land use land cover classification map in Google Earth Engine platform. Okay, so let's check about the accuracy about this map, and then if the accuracy is not good, then you also try to use the different types of approach for increasing the accuracy. Okay, such as the one approach is that we can simply add here the external band. Suppose you want to add here the NDVI band, NDWI band, EVI band, okay, BSI band, okay, other types of indices band we can easily add in here. Then also increase the accuracy, as well as we also increasing the training point about this type of classes. Okay, and also increasing the accuracy. Okay, so a lot of way for increasing the accuracy in Google Earth Engine platform about that. Okay, so now we can get our classified image look like that. Okay, so now check about that accuracy. Okay, before the accuracy, anyone any question about that, you can ask me. Anyone any question about this code or any doubt? Any question?
Good evening.
Yeah, good evening.
Hello.
Yeah, I can hear you. Please.
Okay. Now, I have 2 questions.
Yeah, please.
First one is when we want to choose a training point, you just using a point,
Yes.
and I don't know if is possible to use like a polygon to select the training point.
Yeah, polygon is also possible, but a polygon has also a problem. This problem is that when you
Yes.
take the polygon, it take the lot of pixel value on this polygon. Okay, and when it across the limit of 5,000 element, then this code is not run. Okay.
Okay, good.
So,
Yes.
yeah.
The second question is about the classifier.
Yeah.
It is possible to show us the other classifier like random forest.
Yeah, we can also talk about that. Yeah, so after the accuracy we also try to discuss about the random forest and which accuracy is good and which classifier is good, then we can easily get the idea about that. Okay, for the classification. Okay, so in this time when I use at this classification regression trees, then I can get the one types of accuracy, and when I use here the random forest, then I can take the another types of accuracy. Okay, so after this accuracy, we also try to change the classification model and also check about the accuracy, what type of accuracy you can got in here. Yeah.
Sir, could you please tell me about the band? You already told that there are some band, different band.
Yeah.
So it is it can affect the accuracy or
yeah, it
the
also
model?
affected. Yeah. Suppose when you want to use here this external band, suppose NDVI, NDWI, EVI, then all of those training point also struck the pixel value about the NDVI, NDWI, EVI. Okay, and our data set is also big, and we can also get the better accuracy from that.
So yeah, for if we use this is the actually urban area because it is Dhaka city. But if we use land classification for agricultural purpose, that time the vegetation, that NDVI band should be used for that one.
Yeah, we can also use that about that for the NDVI. Yeah.
Okay, thank you.
Okay, so let's go about check our accuracy about that. So in this time, for the checking the accuracy, we are using here the test set. Okay, so first of all, our model is the same. Okay, we are using here the same model, and also in this time we are using here the test set. Okay, and then check about the accuracy, all of type of accuracy, and then about this what type of accuracy for the kappa accuracy, then also producer accuracy, consumer accuracy, all types of accuracy we can try to calculate it. Next. Check about the kappa and users and tumors and also overall. So let's go. Okay. So all of this accuracy is the same process. We also try to discuss, not problem. Okay, so let's. Okay, so first of all, when you talk about the accuracy, so first of all, we need to create the confusion matrix table. So confusion matrix table, mainly it is a confusion matrix table, and for that, okay, so I just take a variable. Suppose the variable name is that confusion. You can use any variable name. Okay, confusion matrix, and I need to use the function art in ee dot confusion matrix. Okay, and put all of the things. First of all, array and order. So first of all, array and order. Just I simply call this model. I simply call my data set 20% data set. This set simply copy and then paste here. Okay, and then use a function. In this time, this is my 20% data. This 20% data I need to connect with my classifier or connect with my model, and this is my model. So when you want to connect your data with your model, we are using a function. This function called the classify. The user the classify. Okay. So in this time, this is my 20% data. This data I want to add with my model. This is my model variable name. Simply copy and paste here. Okay. So now it will be add with that. After that, from this classifier, I need to calculate the error matrix. So for that, I can simply use a function error matrix, and this error matrix is the two types of argument: actual value and predicted value. I make a dictionary